Okay, so we keep working on this roof detail, wall to roof transition, and I'm going to change things because there are gaps here that we don't know yet what's going on. And okay, so I need to work with the callouts, the window head. Oh, this is not, it's in the section. No, that's this one. Okay, so this is the callout. Oh, this is the callout, this one. Okay. So we have to work with this. The easiest way when we are refurbishing a building, working outdoors, it's always more complicated. We're working indoors, it's better because we are warm, we are safe. Okay, so if we want to apply thermal insulation outdoors, someone has to stay here. It's a tilted roof. They need safety measures, and they have to remove the tiles, and then, okay, so it takes time. So if you have enough space, and we can find, if we have enough space, just looking at the section, okay, so if this height is good enough, we can have like 2 or 3 inches of thermal insulation below the roof level. And with that, we can solve the thermal breach. Okay, so this can be done. So let's do this first and see what happens. So I want to work in this callout. I'm not going to do it as a 3D option because I don't know what to do. Okay, so I'm not going to do the 3D. It can be either inside or outside the thermal insulation, the extra thermal insulation. So I'm figuring out. I haven't made up my mind yet. So I will work with the 2D detail, and then maybe if I have time, when I decide on the right option, I will do it as a 3D. But if we don't want to waste our time modeling something in 3D, which is very complicated, and then changing our minds, we can do that as a 2D detail, and then the 3D will not be exactly like that, but well, it's not a big deal. So let's do that. Imagine that I have this roof. As I told you, we have this thermal breach here, okay, because we have this board, and we have the joist. So the joist can be a thermal breach. So we need to interrupt the heat flow like that. Okay, so I'm going to apply thermal insulation here at the bottom or in the interior side of this roof. So what is the thermal insulation? It's just a rectangle. So I go to annotate, I go to detail lines. Well, I can go, no, I'm going to use the region, a field region. And the thermal insulating material can be, let's say that we have 3 inches. Like this. I click. And what is this? Well, now I have to change this hatch, but I'll do that later. Then we have this. So what is that? Okay, so here I told you that we have to fix this. You see that we have these elements, and those elements don't go up to the roof level. So at some point, we have to move everything up. Okay, so look at everything we have here. We have to interrupt the wall because we have the beam, but we don't have to interrupt these elements because they can go up to the roof. Okay, so let's do that. And how can we do it? Is this okay? So that's an array. So probably this is a beam or a column, and then I created the array. So if I create the array and I want to change the elements, I have to ungroup them. Okay, so if I ungroup and now click here, Now the base level is whatever, the top level, and the top offset is this. So I can change the top offset. So let's make it 14 feet. And let me see the, okay, it's too much. So let's make it 13 up to this point. Okay, yeah, so that will, yeah. So there is always gaps, and we have to work with those gaps. Okay, so remember that if we select all the elements that we want to change, we have to ungroup them, and then we have to change the top offset up to, in this case, is in my drawing is 13 feet. In your drawing can be something different. Okay, but we have to move it closer to the roof level. The same thing we can do with the board. Okay, so with this board, if this is a component model in place, we don't have to change the level. I think we can move this handler or this, yeah, all the way up here. There you go. Okay. By the way, the same thing should happen here on the first floor. I have to ungroup and move them all the way up. I did something wrong, so for some reason, maybe you did it well, but I didn't copy all these elements here. Okay, so remember that when we were carving the opening from outdoors to indoors, I either used voids for the component model in place, or I used the split option, this split element, for columns. So for some reason, I didn't copy these 4 tiny things. I'm going to copy it now. Remove the constraint and place it here. There you go. Okay, so this element now, yeah, now it has a different top offset. It's level 26. Ugh, it's a mess. But anyway, if we make this top offset 0, yeah, I think it works. Okay, so on and so forth. But that's the idea. Okay, so you have to complete it, and these elements we have to ungroup, and probably we have to move this 1 foot up to the roof. Okay, so we have to do this with all the elements that we have there. Ungroup and move this up. Okay, so that would be the right options. We're doing that in 3D because this is something that it doesn't affect either if we have the thermal insulation here or there. All these elements should go up to the roof. And now on the call out, now I have to see what the hell is that. Here, okay, so look at this. We are looking at this projection. Okay, so this element that we see here is the steel connection between the beam and the column. I don't want to see that because it's confusing. Okay, so this is the stud. This is the OSB board. Okay, and this element is the connection to the. Okay, so well, maybe I can hide it, but we have to be aware of what we are looking at. So if this is the OSB board, I'm going to use the same hatch for this element. Okay, so I override graphics in view. And the cut pattern, it has to be, I don't remember, is the diagonal down? Yeah, kind of. Okay, so if this is the OSB board, it has to be the same hatch as this one. We have the opportunity here because you see that the structure it's thinner than the thermal insulation cellulose that we have here. Okay, so before moving this up, I think we can feel this gap. And sometimes when we have a shape or a gap that it's not regular, it doesn't have a regular shape, what do we use? We use foam. Okay, so what is the foam? Let me see if I can find a picture. The idea is that we can use this gun with foam to fill small gaps, especially when those gaps have a very irregular shape and we can find a panel with the right shape. Okay, so we just and usually in attics, this is what we do, or in basements, especially the corners. Okay, so when we can have a thermal breach in the corner, we can use this foam. Okay, so imagine that we are doing that, or we are using this element to fill that gap that we have between the board and the structural element. So this is irregular, and yeah, so that's what we will have. On this is the thermal insulation that we have applied indoors. We need to cover this with another board. Okay, so I can use another region, field region. And in this case, I'm going to have a 1/2-inch board. And the hatch of this, it has to be OSB or plywood or whatever. So I can override graphics in view by element. And the foreground is the diagonal up. Try something different. Yes, if we have diagonal down, does it look any better? Yeah, okay. But it's the same hatch as this one. And then all these, I can fill this gap with thermal insulation. So I can create another region, field region. And I can fill this gap. Like that. Okay. So now we have, well, be careful with this gap here. Edit boundary to move it up. Okay. So now we have kind of a continuity of a thermal insulation. We have wrapped the thermal insulation outside the structural element, and we have this inside the structural element. This thermal insulation, we need a hatch. Okay, so I'm going to override graphics in view. Element. The background, I'm going to use the solid field, and the color of the thermal insulation, it's a gray, it's 225. Okay. And what about the material? Let's use this. Okay, at least we are consistent here because we have thermal insulation. And we wrap this with the same, with thermal insulation. Okay, so we have thermal insulation outdoors and thermal insulation indoors. And this one, I have to override graphics in view. And it's the same color. 225, 225. And the hatch like this. This is OSB board. This gap that we have here. So I need to create another field region. And we need another board right here. And we override graphics in view. It goes diagonal down. Yeah. Okay. So now we have fixed that thermal bridge. That's the stud. And we will need just an internal finish. The internal finish is not a big issue, so we can have like a OSB board here. So we can have another field region, and we can go up to this bit here. Okay, so this can be OSB. It can be drywall, this kind of gypsum wall, whatever, doesn't matter. Okay, and there's a cavity here, and through this cavity, not here, but yeah, we can have wires or pipes or whatever. Okay, so this can be a drywall nailed to those elements. On the 3D view, yeah, we are not doing this in the 3D, so remember. So what we will need here is just another, yeah, we need another board, and this board can be the drywall. We can do it if we open this. If I go to architecture, component, model in place, this belongs to the wall. And we use extrusion and just a rectangle. Oh, I have to set the work plane first. Here. And now I select the rectangle. That is the, yeah, this is the stud. And we have to go all the way up. Here. Okay. Where is the wall? Here. to move. Okay, so I have to move it in that direction. And now, since this is a component model in place, I can use as a material, edit in place, select this, material, it can be gypsum. I think we do have a gypsum wallboard, okay? So gypsum, it's something, yeah, with this color, whitish or whatever. And now I have to open the void. So if I select it, I edit in place again. I create a void by extrusion. And now I have to open the last layer. We have the window there. So I can set the work plane here. And now I can open this rectangle where the frame is. Model, and now, oh, I have to edit in place. I have to select the void and finish, and there you go. Okay, so that will be the internal finish. Can be gypsum, it can be plywood, whatever, but we need to, yeah, we need an internal finish. Okay, so now in the, in this, well, since I have done this 3D view, this 3D element, I don't need the region, so I can do something like that. There are always gaps, okay, but well, if you look at this, we have always gaps between the wall finish and the ceiling. So there's always a tiny gap there, but it's okay. So that would be a solution with thermal insulation inside the, well, inside. Okay, so if we have enough height here, we can do that. And now we don't have this thermal bridge that we had in the here. It's not a 3D component, remember, but now we don't have the thermal bridge that we had with the joists. Okay, so that's an option. We have the structural element here, and the structural element is surrounded by thermal insulation. All around the structural element, we have a thermal insulation. If we want to solve this thermal bridge using or placing an outdoor or the thermal insulation outside the roof, we can do it, but then we have to do something different. We have to move this up, the tiles and all this. Okay, so I can move it up. Let's say 3 inches. Or 3 1/4. Okay, so now this is a mess because, okay, I have to move all the tiles up. So this is what happens when we have 3D objects, okay? So we have to select everything and keep selecting. And now I think we can move it. let's say 2, 3 inches would be enough up. Okay. So what do I have to do now? So I have to place these thermal insulating boards, and okay, so I have to place another board, and then I have to nail those rafters on that board, and that board needs that thermal insulation. We have the okay, so we have these kind of panels available in the market. So we have this is for roofs. Very. So we have the thermal insulation here. This is rigid insulation for the sidings, and then we have the chipboard or the OSB or the plywood. So we can have different finishes. Okay. So when we have to apply thermal insulation to the roof outside, this is the best option. Okay, so it's just a panel with the thermal insulation here, and then we have two OSB boards. So that would be the most efficient way to do it. Okay, so you see, this is what we have, and sometimes we don't need anything else. We have enough thermal insulation. We can go with a thicker thermal insulation, and we can do that. If we just want to apply an extra thermal insulation to solve thermal breaches, so this can be like 2 or 3 inches, and we have polystyrene, extruded polystyrene, OSB, and even sometimes we can have wires. It's not the case. Okay, so that's what we are doing now. So that's the kind of material that we're going to use. So, and what is that? Basically, it's a region, field region. I'm going to create a board here, a 1/2 inch. And another region. Materials. That's the OSB board. So I'm going to overwrite graphics in view. And the pattern is diagonal down. Okay. And what about this one? This is rigid insulation, so it should be the same material as this one. So I'm going to overwrite graphics in view. I don't want this foreground. I want the background color. So the background color, it's 225. Okay, apply. There you go. And what is the hatch? The same as this one. So I go to insulation. Okay, the thickness, the insulation width is, I think it's 2.5. Select this, 2.5. Yep. Okay. So, what do you want? Outside or inside? I don't mind. Either way, it works. The problem is that now we have done this, and I think it's a mess now. Yeah, look at this. So I have moved some of the tiles. Some of the tiles are not moved, and on the 3D view, we don't have that. Okay, so we don't have the board. If we go for this solution, I think if we are doing this from scratch, if this is a new building, I would place the rigid insulation around the walls that we did here, and I would place rigid insulation there. This is what I would do in my experience, but I can understand that there are different options. Okay, so if we are doing this option that I like better, what we can do is very quickly. I can create the board as a 3D element. So I have to do this with the architecture component model in place. That would be a roof. So first, we need just the board, half inch. So if I pick a plane, so I need a half-inch board here, all the way up. Okay. If we click here, the material that would be OSB. Okay. And the finish model. And now I need another one. Well, first, let's drag this to the right position. Okay, so it's an OSB board. And now we need the thermal, the rigid insulation. And I need to fill that gap. So architecture, component, model in place, roof. Extrusion, set the work plane. Here. And the board. Material, the rigid. And the okay. Are we done? Not yet. Remember that we changed the material of this part of the OSB board because we have to protect this against the water. So now we have to protect this against water too. So I have to go to edit in place. Now I have to go to paint. In paint, I have to select the EPDM. And now I have to click this and it will have a different material. Okay, so we have two extra layers of waterproof, or this can be the waterproof, this can be the air barrier, and this can be the rigid thermal insulation. The good thing of a rigid thermal insulation is that if it gets wet, it doesn't affect the material itself. So it's water resistant. So that's why everything that can be exposed to the rain, I would use this rigid insulation, just a couple of inches or 3 inches. It solves the thermal breach because now we don't have the thermal breach here. Okay, so you see that we interrupt the wood and we have thermal insulation there. And yeah, I think this is a nice detail. And if that's a nice detail in the, yeah, so here in the call out, that's what we get. Okay, so I think now we are done. We have a lot of, I mean, we have more thermal insulation probably than we need. Well, it doesn't do any harm. It's more expensive having thermal insulation outdoors and indoors. But what we have to understand is that the outdoor thermal insulation, especially if it's in the roof, I wouldn't use cellulose or I wouldn't use cellulose. I would use this rigid thermal insulation because it's more reliable, and if it gets wet, it's not affected by the moisture or the water. So that's why we have this here and this there. Okay, so I think now we are ready to go back to the sheet. And we can start placing more text. When it comes to the text, it doesn't work. Oh, I have already defined the element here, so I don't have to define it on the top section. No, it doesn't work like that. We have to repeat the names because someone can be working in this part of the section and someone can be working on this one. Okay, so don't take for granted that people working here will look down to see the materials. If the materials are not in the right place, people or workers will complain. So there are things that are the same. Here we have the rain screen cavity. The waterproof fiber board is this one. We use rigid insulation, but this is a waterproof wood fiber board. We can do that. This is the oak wood siding, okay? This is the air tightness membrane, okay? Now I'm going to use the lines. Now the aluminum seal, we don't have this aluminum seal here. The aluminum seal in this case is here. And we have a seal when it's in this part of the window. I would call this aluminum flashing. I think this is the right word. Okay, so a flashing, it's just an element, usually a metallic element that we place to protect something against water. Okay, so it's a very thin metallic plate, usually made of aluminum. And the goal is to get rid of water or to protect something that it's made of wood or or something like that against water. Okay, so this is what a flashing would be. We have a roll here, well, maybe it works, but yeah, so when we have this, yeah, what is this? This is a roof, and this is a wall that goes beyond the roof. So this connection between the wall and the roof, we have to protect it with this flashing. Or when we have a window, yeah, every time we have an opening, we have to use this kind of flashing to get rid of water. Okay. And tape dressed over plywood sealed to air tightness membrane. I don't know what the hell is that. This is the air tightness. Okay, so we can keep moving. So in this case, that would be a ceramic roof tile. And so we can put names to everything. This is a softwood rafter 3 by 2 inches. Here we will have the same waterproof wood fiber board. So we can copy this here. If we are using the same kind of thermal insulation in the roof and the wall, we can do that. Well, I copied this, but I don't like it. Okay, I want the lines to be parallel. What is this? This is a gutter. I'm sure there is a material for that, uh, let's keep this without material. And with this, we have the window and the triple glazing. So we can copy this here. But now the aluminum frame, okay, so we can move this down. Oh. Okay, so on and so forth. that would be structural glue lump beam. Softwood rafter 2 by 2 inches. By wall. We're getting there. And when we interrupt the detail like this, I think it's better if we don't have a big gap between the two drawings. So I can go to the call out one. And if I show the crop region, I can move the crop region slightly down and then hide it. And with the call out 2, I can move the crop region slightly up and hide it. And let's look at the sheet again. Where the hell is it? This one. Okay, looks better. Oh, I don't need this material on the section, so I have to go to the callout. And if I select all this, override graphics in view, and I don't want to activate the pattern, I want just a blank rectangle like that. Okay. And finally, to make it better, we don't like to finish the detail just like that, like a loose end. So we can use like a detail line. And well, this is the same as the waterproof, so we can find another hidden line and then copy. Here. Yeah. And here we have another section, so we can copy. Oh, this is almost out of the. So I'm going to show you now how to create a new line type. Okay, so if you go to annotate detail lines, here we have the detail line. Okay, so these are the default, and I created this waterproof, and that's the line that we used here. But if we want to, because we have the waterproof layer here, but we want the vapor barrier inside. So it should have like a different thickness or different line style or whatever. So if I want to create a different line type that it's not by default in Revit, we have to go to manage. We have to go to additional settings. It's not straightforward. And then we have to go to line styles. And then on line styles, here we have all the lines that we have. This is the waterproof that I created. This is the line weight. This is the color, and this is the pattern. It's a dash. Okay, so we can create a new one, and let's call this vapor barrier. The subcategory is lines. Yep. Okay, so here we have the vapor barrier. So here we can control the weight. If we want to make it thicker, I'm going to do something that it's going to be bad. So let's do 10, and it's a solid line. Okay, so we apply, we click here. So now when we go back to annotate detail lines, that's the waterproof. And here we should have the vapor barrier. Okay, so this is what I created, something. Okay, so I don't want that. But now I have a new line type here. If I want to change it, I have to go to manage, additional settings, line styles. And here in this water vapor barrier, if the thickness is too much, let's make it 6. If I want to change the color, we can change the color. And we can change the dash. So let's do this dash 1/8, see what happens. Okay, so now the dash is different and the color is different. I'm going to change to make it even. Manage, additional settings, line styles. That's the vapor barrier, and I'm going to use a dash 1/6, apply. Okay, so that's different enough. So now I can use this vapor barrier, and I have to apply this vapor barrier inside the. So if we have this OSB board, so at this side we will have the air, and at this side we will have the vapor barrier. And the key is the continuity. Okay, so I have to continue this. So I have to go to annotate detail line. It's not the waterproof. I want the vapor barrier, and I want it here. Well, this can't be exposed, so probably it can be inside this board. So if it's inside this board, this has to be inside the board too. It's good having a different hatch because, well, I told you that usually we print this black and white, or we make copies, and the copies are black and white. We don't spend a lot of money in color copies. So if we additional settings, line styles, I know I would, the color, I would use black. And with this, now I see the difference between the air barrier and the vapor barrier. I go to the sheet, and now I can copy this text